This I would consider a hard rates problem. So once again, feel free to press pause and try to solve it on your own before pressing play and seeing the solution. So here we have oil on a pan, and just to make things simpler, the oil on the pan is going to assume the shape of a circle, a perfect circle. And since it's three-dimensional, it really is a circular cylinder. Well, that's like the height of the oil, and then that's the radius of the oil. And we want to know how fast the rate of change of the thickness of the oil is at t equals 4 seconds. So we want dH dt at the moment that t is 4. And we know it's going to be negative because after you pour the oil will spread out and get flatter. So this should be negative. Now what we're given is a whole lot of information. We're told that the oil spreads at a rate that's proportional to the square roots of the time since being poured. That means that the radius is proportional to root t, where k is the constant of proportionality. We know after 1 second the radius is 8 and the thickness is 1/2. We can use that to find k right away. When t is 1, the radius is 8, which means k is 8. And so this is the equation for how the radius relates to the time. We also know that after 1 second, the radius is 8 and the thickness is 1/2. So that will come into play at some point. And our goal is to figure out how fast the thickness is changing. So we have to have an equation that relates the radius and the thickness. That's going to be volume. So our main formula is going to be the volume of a cylinder, because that's the only way to relate the radius and the thickness of this cylinder of oil. We can differentiate this because our goal is to figure out how fast h is changing. So for that we need the derivative. We'll use the product rule. There we go. And since the oil's been poured, there's not more oil being added to it, which means dV dt is 0. Because the amount of oil is constant, therefore how fast it's changing is 0. It's not changing at all. And we also need to figure out some other values. We need to know the radius, dr dt, the thickness. Oops, I made a quick mistake. This should be dH dt right there, which hopefully you caught if you're doing it at home. So we need to know all these values. And so let's go through piece by piece and find them all. So this one we already know is 0. To find the radius, well, time is 4 seconds. So we can just use this equation. The radius is 8 root 4, 16. So the r is 16. dr dt, that's how fast r is changing. We can also use this equation, just differentiate it. This actually is not implicit, because this is in terms of our variable time. And so we plug in t equals 4 into this to give us 2. So now we have r is 16. We have dr dt is 2. All we need now is h. To find h, we use the fact that volume is constant. And we know that after 1 second, r was 8 and h was 1/2, which means that the volume is a fixed 32 pi cubic centimeters. And so at this moment in time, after 4 seconds, we know the radius is 16, so we can just solve 32 pi equals pi times 16 squared times h. And then after you divide, that gives you that h at this moment is 1/8. And so now we have all that we need to know to find dH dt. And so again, this is a bit harder question because you have to go searching a bit more for all the information. So to put it all together, I'm going to take this and go down here with it. dV dt is 0. 2 times r times dr dt is 2 times 16 times 2 times h plus r squared dh dt. And then when you solve this, you get dh dt is negative 1 over 32. And since this is the thickness, it's measured in centimeters per second. Okay, so to summarize, if it's a question like this where it's not all clear what to do, just kind of start and just work your way through it. Start with the picture. Think of what formula relates all those values. Think of what you're trying to find. In this case, it was dH/dt, so you had to differentiate this. And then somewhere in the question, everything has to be given to you. So go searching for it all.